The James Webb Space Telescope has revealed to us where the universe ends and what lies beyond its edge. This discovery has shaken the foundations of physics, raising doubts about some fundamental laws. Just how vast is the universe truly, and will we ever uncover all there is to know about our cosmos? Let's embark on a journey together to explore the boundless expanses of the universe and unveil the mystery of its true dimensions. Ever since we, as humans, have gazed into space, we've pondered the question, just how vast is our universe, really? Does it have an end, or is it infinite? For centuries, there was little answer to this question. A century ago, researchers claimed to have found evidence that the cosmos originated from a temporal starting point, an event we now know as the Big Bang. However, the James Webb Space Telescope is now flipping that assumption and challenging many other cosmological principles. Now, we're peering further into the past than ever before, 13.5 billion years ago. That's the light James Webb captures. 13.5 billion years, the age of objects that once emitted this light. We can only look as far as the light allows. If there were a dark cosmic dawn, it forever eludes our view. By peering billions of years into the past, the James Webb Telescope provides insight into the universe's formation and reveals what lies at its edge. Galaxies are so ancient, so massive, so intricately structured that they couldn't have existed based on previous cosmological notions. Yet, they exist, undeniable proof for all to see. With the demise of the notion of a temporal beginning, the theory of a temporal end also crumbles. Could it be that our cosmos has always existed? Just as researchers must reconcile with the idea that time is finite only for us humans, they must contend with the fact that our universe is spatially so immense that we may never find its end. Professor Saul Perlmutter, this means that the simplest picture of the universe is one that goes on forever. In fact, we could be living in a universe where there are galaxies upon galaxies in every direction, up, down, sideways, and it never ends. Since we, as humans, have started exploring the cosmos with telescopes, we've discovered the boundless wonders. Not only do the universe's vast dimensions astonish, but the beauty and diversity of creation can captivate us. And now, let's delve into some dimensions of the universe that challenge your imagination. Right now, scientists are exploring a space that spans approximately 93 billion light-years, and there seems to be no end in sight. We have to come to terms with the fact that despite these colossal dimensions, we're only seeing a tiny fraction of the incredibly vast universe, and we may be glimpsing a part of infinity. I don't think you fully grasp what the number 1 billion truly means. 1 billion is a figure with 9 zeros. 93 billion light-years is a dimension that challenges our comprehension. To expand your understanding of the universe's true scale, let's first break down what a light-year is. A light-year is the distance that light travels in 1 year. 1 light-year equals 63,000 astronomical units. An astronomical unit is the average distance from Earth to the Sun. In kilometers, this equates to approximately 149.6 million kilometers. To visualize this, you'd need to circumnavigate the Earth's equator about 3,729.5 times to cover a distance of 149.6 million kilometers. Or you'd have to travel from Munich to Berlin 258,069 times. Keep in mind, dear friends, that this is just a tiny cosmic space between Earth and the Sun. The observable universe, as of today, spans 93 billion light-years, which corresponds to 5,876,417,284 astronomical units. That's 5,876,417,284 times the distance from Earth to the Sun currently. Scientists believe that the entire universe may be roughly 250 times larger than what we can perceive now. These estimates are based on observations and the findings of modern cosmology, including the concept of Hubble's observable sphere. Hubble's observable sphere is the region of the universe that's visible from our side, as the light from objects in this area has reached us since the Big Bang. If this estimate is accurate, it means that the extended universe has a diameter of at least 23,253,000,000 light-years, or 1,468,820,000,000,000 kilometers. If your brain is buzzing with this, we apologize. It's not our intent. Today, we want to push the boundaries of your mind and help you envision the universe in an entirely new way. Let's return to the almost pleasantly comprehensible distance from Earth to the Sun. A spacecraft would have to travel back and forth 1,468,820,000,000 times to reach a distance that might approximate the diameter of our universe. Now, let's switch to another mind-boggling measure: light. Nothing traverses space as swiftly and consistently as light. For light particles to travel from Earth to the Sun just once, it takes a mere 8 minutes and 20 seconds. To cross the entire solar system in a single journey, light requires approximately 21 hours and 20 minutes. The current dimensions of the observable universe span 93 billion light-years. To cross it once, it would take an incredible 93 billion years for particles of light to do so. I'm slowly shedding light on just how immense the dimensions of our universe truly are. We, as humans, are mere specks in a space that possesses unfathomable proportions. For us, the Sun is already a colossal fiery sphere, and we can only travel to the Moon in bulky spacecraft once. Mars, which is roughly 1.5 astronomical units away, presents a challenge that we're still struggling to fully conquer, especially when it comes to sending humans through space. On the other hand, probes have been successfully exploring the solar system for decades. They are less susceptible to increased radiation, smaller and lighter, and can move fairly swiftly. Among the great pioneers and heroes of space travel currently on their journey are the Voyager 1 and Voyager 2 space probes, launched in 1977. Over this time, they've crossed the boundary of the solar system and are now exploring the outer reaches. It will be several more years before they are entirely in the vast emptiness of interstellar space. Currently, both probes are about 23 billion kilometers away from Earth, roughly equivalent to 153.86 astronomical units. Voyager 1 is hurtling through space at a speed of around 61,000 kilometers per hour. While their speeds may seem impressive to us, these figures are only a tiny fraction of the speed of light. The nearest star system beyond our Sun is the triple star system Proxima Centauri, which consists of Alpha Centauri A, Alpha Centauri B, and Proxima. On average, these three stars are located 4.24 light-years from our solar system. Even if we could travel at an incredible speed of light, it would still take us about 4.24 years to reach the neighboring star system. In contrast, for the Voyager spacecraft to cover the same distance, it would take approximately 70,000 years. The difference between their speed and the speed of light becomes evident here, illustrating the vastness of the universe and the challenges of interstellar travel. We are still moving in the immediate vicinity of our own star, and yet the distances are already staggering. Let's consider that our solar system within the Milky Way is just one of approximately several hundred billion star systems. Our nearest galactic neighbor is the Andromeda Galaxy, with a diameter of 220,000 light-years, nearly twice the size of the Milky Way. Experts estimate that Andromeda contains at least 1 trillion stars. Although Andromeda is one of our closest neighbors, it is located at a staggering distance of 2,537,000 light-years from us. Now, we have 3 galaxies to contemplate, and in the known universe as of today, there are at least 100 to 200 billion galaxies. Once again, our minds approach their limits, and it becomes even more profound if we consider not just matter, including stars and galaxies, but also the vast expanses, the voids, the non-existence. Here, it becomes clear that exploring the universe will continue to be a complex endeavor, even when humans can travel through space at speeds surpassing that of light. Let's not forget that, as of now, nobody knows for sure whether our universe has a definite end or not. Let's return to the recent discoveries made by the James Webb Space Telescope. Scientists had hoped that the telescope would allow them to peer into the dawn of the universe, the time just after the Big Bang. Perhaps they were hoping to find the first stars, the earliest star clusters, or galaxies that would show that the most ancient of them were significantly different from today's galaxies. Instead, researchers found galaxies that had, at the very least, the same pristine forms as contemporary ones. Spiral, disc-shaped, or spherical galaxies, it appears they existed over 13.5 billion years ago. Since then, the temporal beginning of the universe has been under scrutiny. To be precise, researchers have not found any evidence in the oldest light traces to suggest that the universe is somehow contracting, as one might envision in a scenario where the lifespan goes from chicken to egg. It almost gives the impression that the universe has always been the way it looks now. Now that you have a better understanding of the vastness of space, you can appreciate how challenging it is for scientists to survey and measure space of such magnitude and fit the direction of motion and dynamics into a coherent context. These efforts are akin to an ant using a calculator to navigate a colossal structure of the sky. What do you think now? Does it even make sense to search for such answers? And can you imagine an infinite universe?